Good morning, mathematicians. We're back as usual. We're going to return to our reading of the FPP conjecture paper. Yeah, that's what it is. Unless we get sidetracked by other questions from chat, which, it happens. That's what we're here to do. But actually, before moving forward in this paper, I do want to crunch out an example, because that is what helps me understand these things. To make sure I've understood them correctly. So, to that end, let's recall, I meant to open this document before. That's okay, I'll figure it out. I want to work out this statement for GL2. And so, if you recall, the irreducible representations of GL2, the non-supracuspidal irreducible representations of GL2 are all labeled by a pair of numbers, by a pair of complex numbers. And, not quite. Two complex numbers together, or two complex numbers as singletons. And the two complex numbers as singletons was just isomorphic to composing the determinant character with the norm and putting it to this exponent. And the other ones are infinite dimensional. Wait a second, though. This is only true, actually. Hang on. This is only true. This is only true when b is equal to a plus 1. Otherwise, it's some other infinite dimensional unirep. I'm pretty sure. Yeah. And in that case, it's an induced irreducible. Yeah. So, but this FPP conjecture paper is about unitary representations, and thankfully Kudla has a classification of the unitary representations. Actually, it's not due to him, but this is just somewhere I know to go where I will find it. By the way, I have a version of There Goes My Hero by the Foo Fighters stuck in my head, but instead of he's ordinary in my mind, he's saying it's unitary. So that's fun. Good morning, Tenacity. Good morning, Thomas. Or good afternoon, Thomas. Milton has unsubscribed. He'll be back. They always come crawling back. Yeah, so let's find our classification of unitary representations here. Here we go. Unitary representations. I think he even explicitly says what they are. I think he even writes them out for GL2. So the essentially square interval representations will be supercuspidals together with these for any character of F cross. Are you saying those are twists of Steinberg? Getting started on homology this week. Hell yeah. Wait, did I get these things wrong? I'm trying to think. No, the quotient of this guy is Steinberg. So Steinberg should be this one. Oh yeah, okay, twist of Steinberg. Yes, okay, that is what it is. Okay. By this theorem, this and that, and this and that, tempered representations, and the irreducible unitary principal series, where the two characters are unitary. Okay, so is this classification saying more than Bernstein-Zelevinsky? You mean the multi-segment? No, this is well, Bernstein-Zelevinsky don't talk about unitary representations, but this is the Bernstein-Zelevinsky multi-segment theory. Actually, this is a backwards version of it. So they do a version with sub-representations, and this is a version with quotient representations. My preprint that I had believed was going to be out by the 1st of September, which is still very much on its way, will talk about some of the relations between these different things. But it's all, elsewhere in the literature as well. But it won't talk about unitary representations. And this unitary stuff is, yeah. So, what does that mean for these things? Well, that means that in particular, so these being unitary means that now this should be for real numbers, A and B. This thing will be an induced irreducible unitary representation. This case are the irreducible principal series representations. Irreducible unitary principal series. The remaining non-tempered unitary representations are the complementary series for any unitary character and alpha between 0 and -1/2. So, okay, so that'll be... So alpha is between 0 and 1/2. And we have Q. What is it? Okay, and then we can twist that by something unitary. So A, maybe I'll call it even Z. it's complex. Wait, is that even allowed? Those don't differ by 1. Oh no, they will. They will differ by 1. Nice. Oh, this one should be negative, and this one should be positive. And the unitary characters. Right. So those will be when 2a plus 1 over 2 is purely imaginary. So here's our 3 cases. And now the FPP conjecture says that for the infinitesimal parameters in each of these cases paired with the co-roots, we should get at most 1. Yeah, irreducible. Where, of course, well, this should mean the element of the Cartan corresponding to that. And so, well, let's check it out in this case first. So, the infinitesimal parameter in this case should be the does the full proof go case by case on these? Wait, the full proof of what? The FPP conjecture? I don't think so. I mean, what's happening in this paper is much more general. I mean, we'll have to look at the proof. But definitely, because we're just talking about the GL2. We're just talking about GL2 here. Thoughts on 2 plus 2 equals 5? Not my favorite Radiohead song. That's my thoughts on it. So it should be this, where this character evaluated at Frobenius, or this is a matrix, evaluated at Frobenius, should be QAI QBI. And so this should be the exp of AI log ln Q and BI ln Q. Yeah. Any good books for complex analysis for undergrad? Well, depends what you mean by good. Books. Yeah, I recommend Conway to people, which might seem insane, maybe. Because actually, having gone through it in detail with some tutoring students recently, it is not the most gentle, but it's got a lot of stuff in it. Which is really good. So, I don't know. Maybe it's not the best place to start, though. But if you do start there and you do survive getting through the first little bit, then it'll make you strong. Don't read, was it Ian Stewart's book on complex analysis? It's fine, actually. It's just I remember there being a lot of typos, and I was upset about it at the time. How does it rank in the leagues of literary devices? Wait, were you asking about 2 + 2 = 5? How it ranks in literary devices? I rank it 2 + 2 out of 5. What is my favorite Radiohead song? That's a good question. I don't know. There's a lot of really good ones. I don't think I would pick a favorite. I don't think I'd pick a number one favorite, but I like Weird Fishes. I like Karma Police. Oh, I know, so bland, so vanilla of me to like Karma Police, but I do. It's a great song. Pyramid Song. Yeah, I don't know. I like Kid A. And In Rainbows. Everyone likes In Rainbows. I don't know. There's a lot of, I don't know. There's a lot of songs. I would never pick a favorite. I like, I like music that has weird time signatures and is sad. So, Radiohead, Chopin. I like a lot of other music too, but what do I think of Sherbert and Bartle's Introduction to Real Analysis? Have I read it at all? No, but I have read Bartle's Measure Theory book. Yeah, Jigsaw is also another classic. I really like, John B. Conway's Functions of One Variable. I really like, there's this guy, what's his name? Adam something. He does covers on YouTube, and he does a lot of radio covers, and I don't know why I was strumming an air guitar there, but only like songs about unitary reps. Yeah, fair enough. Okay, let's get back to unitary reps. So actually, hang on a second, but this is a little weird. I guess I'm unclear. I'm kind of half guessing about how we're defining the exponent here. Because what if the infinitesimal parameter is ramified? This makes sense to me. Oh, I listen to tons of math rock. Yeah. In like 2015, I flew to New York to go pay $10 to see Drafts live, just because I love them that much. I've also sang on stage and partied at an after party with TTNG in like 2017. Fun fact. Yeah, I love math rock. Prog metal, not as much. I went through a metal phase in like, say between junior high and the end of high school. I still like metal, but not as much. I'm more into weird than heavy, but of course I'll listen to, I don't know, something brutal or some grindcore now and again. They do have this example here where they do unramification. Okay, they take the unramified thing. Okay, nice. Okay, that answers that question. So, let's get back to where we were in the paper. I think I was just at the statement of the conjecture. And let's see if I can... What? Where was the statement? Okay, whatever. We're sort of not reading it right now anyways. I gotta try and compute this. So... Right. What are our roots? Don't we just have... So this should be the root pairing, probably, not the. I gotta check out Tesseract's latest album. Well, I wouldn't. I mean, the fact that it's not really heavy isn't either. It's not here nor there for me at this point. I could still go listen to something brutal these days and enjoy it, but I will keep that in mind. I will listen to Tesseract's new album. For me, I think one of the greatest bands, one of the bands that I love the most in recent history is Black Country New Road. And I think their new album is incredible. And it's also fantastic that I think it's incredible because, of course, it's very different. They don't have their front man who led the first two albums that made me fall in love with the band. And it's really changed things. But I'm so obsessed with their new album. Didn't care for the new stuff, Thomas? Fair enough. Yeah, I mean, I wouldn't hold it against you. It's very, yeah, it's very different. But it's, yeah, it's definitely up my alley. I can say that much for sure. This is off topic, but reminded me of Dan Snaith, who's a Canadian musician with a PhD on modular cymbals. Nice. Maybe I'll have to have him on to interview about math and music. Is that IJ, capital IJMC? If you do like heavier stuff, I wouldn't say that any of their music is heavy, but you're more likely to be interested in their first album. There's definitely darker things happening in that album. So, and you should start there anyways if you haven't heard it already. Okay. But we got to do this computation. So the element in the Lie algebra that we're looking at should be AI ln Q bi ln Q, but we're looking at the real Cartan. We're looking at the real Cartan, and so yeah, let's find where we are on the paper. Right, so we have our characters, we've tensored up here. The standard triple for G. Wait, is G the dual group? Okay, wait. Bold G is the group. And little g is the K points. Right. Okay, makes sense. Okay, so we should be able to read this off from the standard triple then. We should be able to read this off from the standard triple. Right. If we use the Langlands correspondence, right? Is that where we're? That should be where the new is coming from that we're looking at. But this says it's new of the infinitesimal parameter. As a dominant element of the dual real Cartan. But then what's the real Cartan? We have to restrict scalars or something here. Or maybe the other way is if we use the Langlands correspondence. Because if we use this one, this should be isomorphic to, let's see here. So QAI-BI will be isomorphic to nu A plus BI over 2 tensor tensor A minus BI B minus AI. And now the point is, I know this probably doesn't make sense to anyone what I'm doing. This thing is tempered because this multi-segment is symmetric. And so the Langlands data for this should be G tau A plus B. Wait, no, this I shouldn't be here. Now I'm confused. Now I'm confused because I want to make this symmetric, but also the character that we twist the tempered by should have real exponents. Oh no, maybe this is fine as it is, actually. Maybe this is fine as it is. No, I'm pretty sure to be tempered it has to be a balanced segment. But maybe it only has to be balanced in the real direction. Yes. Okay. Never mind. I'm going in circles. Okay. So then actually, wait, is this thing tempered already? What does Kudla say? What does Kudla say? What does he say to me? What does he say to me in this document? Also, hi to my mom. Mom, if you're watching. My mom watches sometimes, even though she doesn't understand anything I'm saying. Good morning, Mom. does he talk about tempered? Twists of Steinberg should be tempered. I guess this is... No, wait. Twist of Steinberg doesn't have to be tempered. The tempered representations are discrete series and unitary twist of Steinberg. Right, and this is a unitary twist of Steinberg. Okay. So actually, then... this is the tempered for its own Langlands data. And so that means that we have 0 here. So going by that, of course, 0 paired with all the co-roots is 0, which is less than 1. And let's see if we can square that with here, because I wonder, now I'm just vibing this out here. But I wonder if taking the real Cartan here basically means that we have to take the real part of the exponent of our Langlands parameter, which would check out in this case, right? The real part of this is 0. So I'm really doing vibe-based mathematics right now, but that is consistent. So why don't we check out the other case? If we had, so if it was z plus alpha, z minus alpha, let's see if we did it this way. We took the real part of that. So that would be the real part of z. I don't know. I'll call that a plus alpha, a minus alpha. And we'll pair that with the co-roots. Now, we're in GL2, so we should just have one root, right? We should just have this root. So we have one co-root to pair it with, right? And now the root pairing is linear in the first variable. So this is a plus alpha, a minus alpha, E1 check minus E2 check. Because this should be, I mean, this is the inner product, if I'm doing this right. This will be the inner product of this with this over the inner product of the root with itself. If I've done this correctly, right? Is there anyone in chat who can fact check me on my root system stuff? Or has everyone gone silent? Because I'm really in the weeds here now. Looks good to you. Thanks, Thomas. Great. Then it must be true. Oh, yeah, here we go. Oh, it's 2 times that. Is it 2 times that? What is the... Maybe, let me type it this way. Relationship between root, pairing, and inner product. Oh, sorry, Arad. Maybe you're right. You're right. This should be evaluation, which actually should work out to the same thing, right? Doesn't the evaluation pairing work out to the same thing? I think it does. But no, you're right. So then this will be E1. Wait a second. And E1 is 2, right? Yeah, I'm confident it works out to the same thing, but okay. So this will be 2a plus alpha minus 2a minus alpha. Oh, that's got to be it, right? Because then those cancel, and we're left with 2 alpha, but alpha was in between 0 and 1/2. And so that's totally consistent with the FPP conjecture. Okay. Despite the fact this is vibes based, we must be right. We must absolutely be right. Good morning, Ken. Good morning, Ken. Nice to see you. Yeah, nice. Okay, so we've all internalized the conjecture now, right, gang? we're all on board. Okay, now let's dive in. I guess we're in the notation and preliminary section still, right? So we've got our Langlands classification theorem. Says that we can go from triples, defining all of our unirreps appear as quotients of these induced representations. Got a bijection, to triples, where we've got a parabolic, a tempered, and a p-positive character. Got, Langlands parameters, enhanced Langlands parameters, tempered enhanced Langlands parameter, right? Tempered means we're bounded. Projection to the dual group is bounded. Of the image is bounded, yeah. Z, okay. For any K-Levy subgroup, Z of the L group, 0 sub H, denote the subgroup of the complex torus of the torus of ZL and 0. So that's a connected component of the center. Consists of the hyperbolic elements. And then we have a natural identification here. I've never quite got my head around hyperbolic and elliptic elements. I know it's a simple thing, but I don't feel it in my bones, you know what I mean? What does ZV mean here? Oh, I guess we're just saying there is an identification. ZV is going to be the thing, or Z new is going to be the thing that we identify. And then they point us to this resource. Gotcha. So if we have something in the center and we have a Langlands parameter, that's what PLM means, right? A Langlands parameter of, Langlands parameter for M. We will define the Z twist of phi to be phi to the z, where dw, okay, wow, okay. So w, I see. So w is the number where if you take the absolute value of the norm of w, that's going to be some power of q. dw is that number. We put it there. Okay. Maybe I should write that down. So z in here, phi z, wx will be defined to be phi wx z dw, where w is qdw. Make sense to everyone else? Yeah, I imagine maybe my class field theory walkthrough is more entertaining for everyone. This is these office hours are just for me now. This is deep in the weeds of research that I care about. Okay. Standard triple is of this form, where these, an enhanced standard triple is of the form where, so that should account for the local system. You're as entertained as you are confused. Nice. Great. I mean, that's what I'm going for. Right, so tau should be the representation of our component group. And right. Right, okay, yeah, that makes sense. Yeah, that's just a representation of our component group. Then, okay, we're ready for this theorem. So suppose this is a standard triple for the dual group, then the z twist of this by phi is an L parameter. Wait, for LG? Wait. Suppose we have a standard triple. It already is a triple for LG. Oh, right. Phi t is a Langlands parameter for LM. So z twist it, compose with the inclusion. That's an L parameter of LG. And that defines bijection between the set of standard triples for LG and Langlands parameters. Right. Yes. Okay. Makes sense. And a Langlands parameter corresponds to this triple. If it corresponds to that triple under that bijection, then the group homomorphism is an isomorphism. Thus, the bijection lifts to a bijection between enhanced standard triples and enhanced parameters. Wait, what's an enhanced? What is S of phi sub t? Hang on, I skipped over that part. Yeah, this is the centralizer. S sub phi is the component group. What is S of S sub phi t? Oh, is that's the component group? That's the component group as a Langlands parameter of M. Really? Okay. I'll believe it. That seems freaky, though. If I think about what's happening geometrically on the level of Vogan varieties, it doesn't seem like that should be happening. But maybe I'm misunderstanding something here. We will move forward, though. Oh, no, maybe it's just... No, maybe it makes sense. Oh, because this is, like, the tempered L parameter. So that... I see. Okay, it makes sense to me that would work out, if that's the case. If I'm understanding things correctly. Today, finally, we recall... Wait, today... Okay, it's time to end stream. I wanted to get to here. We will pick up with section 2.4 tomorrow. Or random questions from you guys. I don't know. Maybe we'll talk about more music or something. But I will read more of this paper tomorrow. Okay, let's just try and grok this theorem statement, and then your favorite takeaway so far is that we have these data equivalent to Langlands parameters, but more explicit. Yeah. Well, and it should be compatible, right? If we have, representations can be defined in terms of these triples, parabolic, tempered thing, character thing, and there's some sort of bijection between representations and enhanced Langlands parameters. So you should think, well, then enhanced Langlands parameter should also be parameterized by some triple of like parabolic thing, tempered thing, character thing, but all happening on the dual side. So suppose this Langlands parameter corresponds to this triple, and we take a representative, then the hyperbolic part, which is just evaluation at Frobenius, is independent of Frobenius. Moreover, if we if we take the corresponding parabolic subgroup, determined by the hyperbolic part, by which we mean we take the centralizer, then this triple is conjugate to this triple under the dual group. Okay. So we will pick up here tomorrow with the local Langlands correspondence. So until then, go prove some stuff. Go work out. I told you other cases of the unirreps for GL2. So, go work out the FPB conjecture in those cases. And